Welcome to Prof.Ahilaa Max, Plus 2 Mathematics, Tamil Nadu State Board Syllabus, Chapter 1, Application of Matrices and Determinants, Video 1.25, Exercise 1.3, second, third, fourth and fifth problems, solving system of linear equations by matrix inversion method. Steps to matrix inversion method. First one is, write the system of linear equations in the matrix form, that is capital AX equal to B. Second step, check if determinant A not equal to 0. Then A is non-singular. Therefore, we say A inverse exists. Third step, find A inverse using the formula 1 by determinant A into RJ. Fourth one, find capital X equal to A inverse B. Exercise 1.3. The second, third, fourth and fifth problems are like this. Let us see one by one. The second problem of exercise 1.3 is, if capital A equal to a 3 by 3 matrix minus 5, 1, 3, 7, 1, minus 5, 1, minus 1, 1 and capital B equal to another 3 by 3 matrix 1, 1, 2, 3, 2, 1, 2, 1, 3. Find the product AB and BA and hence solve the system of equations x plus y plus 2z equal to 1, 3x plus 2y plus z equal to 7, 2x plus y plus 3z equal to 2. So here two 3 by 3 matrices are given and they are named as capital A and B. We need to get the product matrices AB and BA and hence we need to solve the system of equations given. 3 equations given with the 3 variables, okay? And hence what is there means we need to use the first result to attain the second one, okay? So let us find AB first. Use the A matrix given and B matrix given. By usual matrix multiplication, we find AB value. We are getting it as 4I3. So AB equal to 4I3. Similarly, we find BA. So simplify by matrix multiplication. Here also we are getting BA equal to 4I3. Therefore, AB equal to BA equal to 4I3. So dividing by 4 and associating that with the A, we get 1 by 4 into A into B equal to B into 1 by 4 into A equal to I3. By definition of inverse, product of two matrices gives the identity matrix, means those two matrices will be the inverses of each other, okay? So here we get the inverse of B as 1 by 4 into A, that is B inverse equal to 1 by 4 into A. Therefore, from the first result, we are getting a formula for B inverse, which is 1 by 4 into A. So, with this result, we move to prove the next one. So, we need to solve these three equations using matrix inversion method, but with the previous result what we have got, okay? So, let us write the matrix form of the given system of linear equations, that collect all the coefficients of the variables as capital A and the variables as capital X and the constants in the right hand side as capital B. Therefore, we are getting the coefficient matrix as 1, 1, 2, 3, 2, 1, 2, 1, 3. Variable matrices X, Y, Z and constant matrices 1, 7, 2. Now compare this coefficient matrix with our given matrices. So our given matrices are A and B. With this matrix match with our capital B given, okay? So instead of this coefficient matrix, we write that as B. So we are getting B into the column matrix X, Y, Z equal to column matrix 1, 7, 2. but we want the variables value, no? So we are getting xyz equal to, bringing b to the other side, b inverse into column matrix 172. So what is the formula for b inverse? We have got b inverse equal to 1 by 4 into a. Now substitute. Okay. So instead of b inverse, you put 1 by 4 into a. A is the given matrix A. Okay. Into column matrix 172. So substituting, and by normal matrix multiplication, we are getting the result as column matrix 2, 1, minus 1. Thus, column matrix xyz equal to column matrix 2, 1, minus 1. Therefore, equating the corresponding values, we get x equal to 2, y equal to 1, and z equal to minus 1. So, our solution is x equal to 2, y equal to 1, and z equal to minus 1. You can verify this answer by substituting in the given any three of the equations. Okay? Understood? Fine. Now the third problem is, a man is appointed in a job with a monthly salary of certain amount and a fixed amount of annual increment. If his salary was rupees 19,800 per month at the end of the first month after 3 years of service, and rupees 23,400 per month at the end of the first month after 9 years of service, find his starting salary and his annual increment. Here it is explicitly given that we need to use matrix inversion method to solve the problem. Okay. So let us see how to get the result. So here they have asked to find the starting salary and his annual increment. So let us make these as variables. Okay. Consider these factors, that is starting salary and annual increment as our variables. So I consider x as starting salary and y as annual increment. Okay. Now it is given rupees 19,800 per month at the end of the first month after 3 years of service. Okay. So for this I make the equation. See, the starting salary, that is x, and the increment we consider as y. So after 3 years means it becomes as 3y. So combinedly we get x plus 3y equal to 19,800. Similarly, the statement rupees 23,400 per month at the end of the first month after 9 years of service. Okay. So for this we make the equation x plus 9y equal to 23,400. Okay. Now we write the matrix form of these equations, that is capital AX equal to B form. So collect the coefficient matrix, variable matrix, and the constant matrix. Coefficient matrix is 1, 3, 1, 9. Variables are xy, so column matrix xy, and the constants here are 19,800 and 23,400. So that becomes as B. Okay. Now determinant A, which is 6 not equal to 0. Therefore A inverse exists. So find A inverse using the formula 1 by determinant A into Rj. You know 1 by determinant A is 6 here. So 1 by 6 into Rj, as it is a 2 by 2 matrix. Interchange the main diagonal elements, change the signs of the other two. So we are getting Rj as 9 minus 3 minus 1, 1. Now we need to get the variable matrix, that is capital X equal to, using the formula A inverse into B. Substitute A inverse into B using normal matrix multiplication. We are getting 18,600 as a column matrix. So equate the corresponding values. So we are getting x equal to 18,000 and y equal to 600. So conclusion is, the monthly salary what we have considered is x, no, that is rupees 600, and the annual increment, which is y, equal to rupees 18,000. Understood? Fine. Fourth problem is 4 men and 4 women can finish a piece of work jointly in 3 days, while 2 men and 5 women can finish the same work jointly in 4 days. Find the time taken by one man alone and that of one woman alone to finish the same work by using matrix inversion method. So the method is mentioned here. We need to follow that. What are the variables here? Here the thing to find is time taken by one man alone and that of one woman alone to finish the same work. So let us consider the time taken by a man and a woman as the variables. Okay. So let x equal to time taken by one man alone to complete the work in a day and y equal to time taken by one woman alone to complete the work in a day. So let us consider the work done in a day by a man, which is the reciprocal of the time taken. Okay. So 1 by x. Similarly, work done in a day by a woman equal to 1 by y. So this 1 by x and 1 by y are the work done by in a day by a man and woman respectively. So here in the question they have mentioned for 3 days and 4 days, no? So just by multiplying by 3 and 4 we will be getting the work done for that particular number of days. So for 3 days means we need to multiply by 3. 3 into 1 by x, 3 into 1 by y. For 4 days means multiply by 4. So 4 into 1 by x and 4 into 1 by y. Considering the completion of work per day, the equations are. Now read the first sentence and make the equation. There are 4 men and 4 women jointly in 3 days. So 4 men, so 4 into for 3 days work. So 3 into 1 by x. Similarly 4 women for 3 days. So 4 into 3 into 1 by y equal to 1. So the equation is 12 by x plus 12 by y equal to 1. Similarly, from the second statement, we get the equation 2 into 4 into 1 by x plus 5 into 4 into 1 by y equal to 1. From that, 8 by x plus 20 by y equal to 1. So, since the variables are in the denominator, let us consider small a as 1 by x and small b as 1 by y. So our previous equations 12 by x plus 12 by y equal to 1 will turn as 12a plus 12b equal to 1. Just substitute 1 by x equal to a and 1 by y equal to b. Okay. So similarly, the next equation 8 by x plus 20 by y equal to 1 turns as 8a plus 20b equal to 1. Now by solving these two equations, we will be getting the values of a and b. From that, by reciprocating the values, we get the values of x and y. Okay. So follow the matrix inversion method. Matrix form is capital AX equal to B. Collect the coefficient matrix 12, 12, 8, 20. Variables here are A and B as column matrix. Constants, column matrix 1, 1. So find determinant A, which is 144, which is not equal to 0. So A inverse exists. Now find A inverse equal to 1 by determinant A into Aj. 1 by determinant A is 144 into Aj. Interchange the main diagonal elements, change the signs of the other two. So you are getting 20 minus 12 minus 8, 12. Now substitute in their formula capital X equal to A inverse B. So what is X here? Small ab. Okay. And A inverse B, all the things you substitute, so that by normal matrix multiplication and simplification we are getting matrix AB equal to matrix column matrix 1 by 18, 1 by 36. So what is A? A is 1 by 18. Now reciprocate to get the value of x. So reciprocal of 1 by 18 is 18. That is the value of x. So x equal to 18. Similarly, b equal to 1 by 36 implies y equal to 36, the reciprocal. Okay. So thus our solution is time taken to finish the same work by one man alone, that is x equal to 18 days, by one woman alone, that is y equal to 36 days. Understood? Good. Now the fifth question is, the prices of three commodities capital A, B and C are rupees X, Y and Z per units respectively. A person capital P purchases 4 units of B and sells 2 units of capital A and 5 units of capital C. Person Q purchases 2 units of capital C and sells 3 units of capital A and 1 unit of capital B. Person R purchases 1 unit of capital A and sells 3 units of capital B and 1 unit of capital C. In the process, capital P, Q and R earn rupees 15,000, rupees 1,000 and rupees 4,000 respectively. Find the prices per unit of capital A, B and C. Let us mention, use matrix inversion method to solve the problem. Let us see the solution. Here they have mentioned the variables in the question itself, that is the prices of the commodities capital A, B and C are considered as the variables X, Y, Z per unit. Okay. So here about the earnings of capital P, Q, R are expressed. So we consider, so when we purchase we lose money, no? When we sell we gain money. So in that sense we consider, if that is purchase means the negative value, sells means positive value. So that read this for the second statement. A person P purchases 4 units of B and sells 2 units of A and 5 units of C. So purchases 4 units means that is minus 4B and other 2's are sells. So it is positive. So what is the equation? 2x minus 4y plus 5z equal to 15,000. So the earning of the money is given here as 15,000, 1,000 and 4,000 respectively. No? So similarly, reading the other two statements, we get the equations for Q as 3x plus y minus 2z equal to 1,000 and for R as minus x plus 3y plus z equal to 4,000. So as usual, you follow the matrix inversion method. Matrix form is capital A is equal to B. So collect the coefficient matrix, variables matrix, constant matrix. Next we find the determinant value of A, which is 68 not equal to 0. Therefore A inverse exists. Then find A inverse using the formula 1 by determinant A into adj A. Since it is a 3 by 3 matrix, we need to find the transpose of cofactor matrix for finding adj A. So after simplification, we are getting A inverse as 1 by 68 into 3 by 3 matrix, 7, 19, 3, minus 1, 7, 19, 10, minus 2, 14. So next substitute in the formula capital X equal to A inverse B. Keep it in mind that A inverse is this value and B, the constant matrix is 15,000, 1,000, 4,000. For convenience, we consider the common factor 1,000 out, so that B is 1,000 into column matrix 15, 1, 4. Substitute these values in the given equation. We know the variable matrices X, Y, Z column matrix and substitute other. Simplify by normal matrix multiplication. We are getting the resultant matrix as 2,000, 1,000, 3,000. Okay. So equating the corresponding values, x equal to 2,000, y equal to 1,000, z equal to 3,000. Therefore, price of commodity capital A is x equal to rupees 2000. Price of B, which is Y, equal to rupees 1000. Price of C, which is Z, equal to rupees 3000. Understood? Fine. Video 1.26 contents are 1.4.3 second method Cramer's rule, example 1.25 and 1.26. Stay tuned. Success is ours. Thank you, my dear children.